Okay.
Never mind.
I think the next chapter is Alkenes, is it not?
Chapter 5.
I don't know what chapter 5 is. Is it Alkenes?
Yeah.
Okay. Alkenes. Alkenes are those that have a double bond. What is the hybridization?
SP2.
sp2. What is the electron domain?
The what?
What's the bond angle?
120 degrees.
Bond angle is 120. What's the molecular shape?
Trigonal planet.
Trigonoplane. Everybody has to know that that thing, whenever you see one, is planar. Is that clear? It is planar. It is flat. It's not like an sp3 hybridized carbon, yes?
No.
It is flat. It has a top and it has a bottom. Or you can say it has a side on another side. So I'd rather put it like that and say it has a top and a bottom. Yes? This is flat and it has a top and it has a bottom. I can put it like this and say it has this and that, but I don't know how to refer to it. So I'd rather have top and bottom. You guys can deal with top and bottom, can you not? All right. So this is in general the formula for an alkene. CnH2n. This happens to be also the formula for a cycloalkane. I don't know if I told you this before or not. What is the formula for an alkane?
CnH2n plus 2. CN plus 2.
CnH2n plus 2. Outstanding. So, let's say I were to tell you something like this. Constitutional isomers, some of them might be geometric isomers. It doesn't matter. You draw the isomers, let's say, for C5H10. So you draw anything that fits that formula. So what are you going to do first?
5 carbons in a row.
5 carbons in a row. Nice. 1, 2, 3, 4, 5. And then I'm going to place a double bond. Like before, let's place it at the end. Yes? And I'm going to do it again. 5 carbons on a row. This time, instead of placing the double bond at the end, I'm going to place it here.
Did you last class say to remind you to talk about the hydrogen index deficiency?
Index of hydrogen deficiency. Yes, we are going to talk about that now. Now, I'm going to tell you there is a difference between this double bond and this double bond.
On the third.
Yeah, you draw that. There's a difference. This double bond here is called trans, and I'm not telling you why. And this is called cis. And cis most of the time means what?
Same
Same
side.
side.
Same side.
Okay, so here's a double bond which is flat. And that group and this group, which are the biggest groups, are on the same side. You see it or no? While this is the double bond, and this group and that group, which are the biggest, are on opposite sides. So that is called trans. I'm going to talk more about that later. What else can we draw? If I draw this again, and I put this double bond there, is that a new one?
No.
No. This is not a new one. This is one like that. Yes. So what we can do now is, instead of having 1, 2, 3, 4, and 5, I am going to have 1, 2, 3, and 4. I'm going to do this branch, and I'm going to make a double bond somewhere, like here. going to do that again. If I put this double bond down here, is it different from this or is it the same? If I put it down here, it is the same as this, okay?
Yeah.
So I can't put it there, I gotta put it there.
I don't see where it says.
I said, don't worry. If you didn't catch it now, don't worry about it because I will talk about that later. It is cis because if you look here at the double bond, that carbon and this carbon are on the same side.
Okay,
Yes?
I see, yes.
Same
yes.
side. Can I draw another one? Draw one like this. Is that the same or is that different?
That's the,
No, it's the
That's the
same.
same.
It's the same.
The same as what?
Well, the double bond is on a different side, isn't it? The double bond is on a different
oh,
side
yeah,
from that
it's the same
one.
as the first one, no?
It's on a different side from the first
So
one.
it's not the same.
It's on a different side. The double bond is on a different side from the first one.
I don't know what a different side means. I'm asking.
One.
Is it this? Have we drawn this one before?
No, we have
Is that a new one or is
Yeah,
that
that's
different?
a new
one.
It's a new one. Perfect.
Yeah.
We could also, if you count the number of hydrogens, how many hydrogens are here? Count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 in there. Okay, that's C5H10, yes? How about this? Is that part of the rules? Does that fit the rules, yes or no?
One, two,
C5H10.
Uh-huh.
This is 1, 2, 3, 4, and 5. So we can have a ring, and it has the same formula than an alkene. Okay? We are going to calculate something called IHD, and this is called index of hydrogen deficiency. And this IHD is used to find out how many double bonds or how many rings something has. I'm going to tell you, one IHD means one ring or one, let's not write double bond, that's too much work, or one double bond. Two IHDs, what does it mean? Two rings, two double bonds, or
One ring, one double bond.
one ring, one double bond. Is that clear? Or one triple bond. A triple bond has two pi bonds, and that is two IHDs. And an IHD is caused because when you have a double bond, let's say you have this before. Yes, let's say you have that. That is the alkene. And you were to make a double bond between those two carbons. What have you taken off?
Two hydrogens.
You have taken off two hydrogens. But if you were to make a triple bond, you have taken off how many?
Three.
4 hydrogens.
Oh, yeah.
Okay, you have taken 4 hydrogens, which is 2 index of hydrogen deficiency. That is 4 hydrogens. I'm going to tell you how to calculate this stuff now. Of course, there's more combinations, which Sophia is going to talk about at some point. So, let's say this is what you, IHDs. This is how you calculate it. It is the alkane from H, from the alkane, minus H. Let's say this is the H from, let's say given. Can we say given? Given in the formula, divided by 2. So calculate the IGDs for C5H10. What you have to do is the alkane for 5 carbons is supposed to have how many hydrogens?
10,
C5H 12. That is the amount of hydrogens the alkane is supposed to have. That's the number that goes here. Hydrogens of alkane.
Oh,
IHDs. This is 12. Minus the hydrogens given in the molecule. Now how many is that? 10 divided by
2.
2. So this is how many?
1.
That is what we did. It has either one double bond or one ring. Calculate the IHDs and possible structures. Okay, so what do I write?
12 minus 8.
12?
Minus 8.
Yes, you write 12 because if you have 5 carbons, the alkane that has 5 carbons will have
12
12 hydrogens minus
8. So you end up with 2.
divided by 2, so this has
2.
2 IHDs. So what are the possible combinations for 2 IHDs?
2 rings.
2 rings,
2 double bonds, 1 ring,
2
1
rings, okay.
double bond, 1
2
triple
double
bond,
bonds and
1 triple bond,
1 ring,
1 triple bond,
1 double bond or 1 triple bond. Now you draw structures that have those in. Possible structures.
2 rings,
I don't know, you
2
draw them,
double bonds,
see what you can do. Okay, you guys did it? Kind of?
Kind of.
1, 2, 3, 4, 5. Yes or no?
Yes,
What do we need to have?
double bonds.
2 double bonds, yes?
Yes.
1 double bond here,
One
the other
there.
double bond there. Yes?
Yes.
And we are going to do this again. 1 double bond here, the other double bond there. You agree? They're different compounds. If I leave this double bond here, put this one here, what have I done? I have made the previous one, yes? What else can we do? You want a ring? Okay. 5-member ring. 1 ring, 1 double bond. What else can we have? 2 rings? I mean, maybe we can try to draw 2 rings like this, yes?
Can we have an attachment with 2 of them or no?
Maybe we can have 2 rings like that, yes? But this would be a cyclo what?
Propane.
Cyclopropane.
Propane.
This will be a
Butane.
cyclobutane and then a bridge. That's crazy. I mean, you can draw it, okay? But is it a good structure? No, not very good, okay? What else can we have? We can have a triple bond. If we have a triple bond, it's going to look like this. A triple bond is linear, yes?
Right, with SP.
How many carbons are there so far?
1, 2, 3. 1, 2, 3.
1,
5.
2,
5.
3, 4.
1, 2.
That's 5. Yes? This alkene, I mean, it's not an alkene. This is an alkyne. So when it has a triple bond, it's called an alkyne. When it has a double bond, it's called an alkene. This, when it has 2 double bonds, is called a diene. So ene stands for alkenes, yes?
Yes.
Dienes. This alkyne is an internal alkyne. Because the double bond is, the triple bond is in between those carbons. But we can have 1, 2, 3, 4, 5. Is this another possible structure where the alkyne is ending the chain, yes? This is called a terminal alkyne. These are things you have to remember, because I am going to say a terminal alkyne reacts to form this, and I'm going to say an internal alkyne reacts to form this, which are 2 different things. So if you don't know what an internal or a terminal alkyne is, Sophia will ask in your place. Yes, Sophia?
No, terminal side, alkene.
Oh.
No,
At the end?
internal.
Was that the end?
Internal. They're both alkene.
Well, she got it, Maria. You don't know.
I do know.
You don't know she got it. That's what I'm saying. What else? What else can we draw? Anything else? Hello? 1, 2, 3, 4, and 5. Is there a way for us to draw 2 double bonds here somewhere? Maybe we can draw 1 here and 1 there.
What about drawing a square with a projection and a double bond?
We agree that a square is not so good. Because it's cyclobutane. You can draw it, but it's not good.
Oh, I thought it was not good because it had a bridge.
It's not good because it has a cyclopropane and a cyclobutane and a bridge.
But it's not, if it's only 1, because there you have 2 and a bridge. If you have no bridge and only 1.
It exists. I mean, cyclopropane does exist. We just don't want to draw it.
This is a diene as well.
Yes, it is.
And how do you know how many possible structures
You don't. You just draw as many as you can and pray. What else, guys? How about this one? Is that different or the same?
The same.
Yeah, that one and this one is the same. It doesn't look the same. And you will learn
What if you put
soon
that
enough
one?
that it's not the same. But yeah, if you flip it, you go like that, that will go that way. So they are the same. Okay, and they look different.
Them being the same and different is determined by what carbon they're attached to.
Now the difference is determined that these two double bonds are on the same side, while these two double bonds are on opposite sides. When we do cycloadditions, you will find out what that means. You are going to love that section.
Can you put one in at the top?
Would it be different if the double bond on this side, if it was on top?
Yeah, that was my question.
What?
If
Okay, you
move-
see how you
you
put
move
the
the bottom
double
to the
bond on the
top.
bottom? Would it be different if it was on top?
That bottom one, you just put it on top. On the
Maybe
first
here?
carbon, yeah.
No, okay.
Is that one?
Here?
No, on the first carbon.
The bottom line, okay, the bottom line on this carbon.
The bottom line.
Erase
On
it.
the other, no, oh my God, Garcia.
I'm not inside your head, you gotta
This
realize
side.
this.
Okay, your molecule, right? This, the end, and the terminal, you see how it's the bottom? Over my, okay, left. Left. Okay, yeah, you see that double bond? Okay, the line was on top.
Here?
If the bond was literally right above it instead of under it.
What?
Doesn't
I think
matter.
that's what she means. The double bond
It
is
doesn't
under,
matter, right?
put it on top of it. Makes a difference.
It doesn't matter.
Like this?
Yeah.
Like that.
Doesn't matter? It doesn't matter.
Goes down.
It doesn't matter.
I'm asking now, is it?
And what? And what do I do with the other one? Like this here, or what? I leave it here?
Yeah, is that, it's still the same? I'm asking if that's still the same.
Yeah, it is.
Okay.
It is. Whether you put, look. For you to realize, if I put the line outside, it's the same thing if I
Put the line inside.
put the line inside.
Yeah, it doesn't matter.
Doesn't make a difference whether it's above, below.
That's what
I
I'm
gotta
asking.
put it
Okay.
somewhere.
All right.
Yeah. What else? Let's do nomenclature, since you guys are so excited about this. By the way, I'm gonna give you homework, okay, since you like homework so much. I want you to find the IHDs for the following.
Is this homework for us or we're trying to?
Uh,
You can plug more.
Homework for you. Yes. You and I are going to turn this in. I want you to find the IHDs and possible structures for those for next week. For next week. No, not for now, for next week. I did not explain how to find it, so you have to look for it.
IHD and possible structure.
And you want us to list it or actually?
I want you to find out how to calculate the IHDs for that. I want you to draw them out and come next week. If I imagine you guys did not do it, I'm gonna give you a quiz. Okay? So, so what is the name of that? What you are going to do is, you are going to count the longest continuous carbon chain, like you did before. That contains the double bond. So you are going to go. You are going to start closest to the first substitution. The substitution is the double bond, yes?
Yeah.
So you start closest to the double bond or to the first substitution. Whatever comes first, double bond or substitution. So you're gonna start here. The chain is going to look like this. So this is carbon 1, 2, 3, and 4. On carbon 2, what do you have? That method.
Could also be
Now, you always have to say where the double bond is.
Yes.
Now, where is the double bond at here? Carbon 1. So this is called 1, 2, 3, 4, butene. The ending is ene for alkene. If the ending were ine, it would be an alkyne.
Would that also be sec butene?
What?
Would that also be sec butene?
Sec-butene.
Do we prioritize the double bond or just?
Double bond. Okay.
So if they're on opposite sides, we start off closer to the double bond?
Yes. Okay, now let's make this harder, okay? Look.
One, two, three bromo. 1, 2, 3, bromo. 3 bromo. 3 bromo. 3 bromo.
Some people complain from the classroom that I did not give enough nomenclature on the last test. Apparently you wanted more. So on the next test we'll have more, okay? I want to make you as happy as I can possibly make.
Who said that?
Hmm?
Who said that?
I can't say. You think I'm some type of snitch?
Stitches get stitches.
Snitches get stitches, that's right.
So it's gonna be 1 method. 1, 2, 3, 4. So it's gonna be 4 bromo. 1 methyl, 4 methyl. 1
Guys, you passing around the attendance or what? Oh, the last 4, right?
4 bromo hexene. Is it 1 methyl 4 bromo hexene? 1 bromo, 1 methyl 4 bromo
And then it's
hexene.
2 hexene.
Still on the
You did not
second,
sign?
so.
Why not?
So it's 2 methyl, my bad. So it's 2 methyl 4 bromo hexene. 2 methyl 4 bromo hexene. 1, 2, no? Now basically it's just.
Okay, let's do it.
So it's just a bromo group.
Yes?
2 methyl.
Where do we begin?
The right to the left.
One,
To left.
2, 3, 4,
5,
5,
6.
6.
So two
So at least this will be 2
hexene.
hexene. Yes? It also has a methyl group. What position is this methyl group on?
Two.
This is in the 2-methyl position. It also has a what else?
Bromo.
4
Bromo.
bromo. You agree?
Yes.
Now the problem with this 4 bromo is that this is chiral. And if it is chiral, you have to say whether it is R or S.
Oh Lord.
It gets complicated, I
What
know.
about that nomenclature?
So the
Nomenclature? No.
is so it's R. So it's R. So
Yes, you are
4R
going to have this
bromo.
nomenclature on the test.
So you call it 4R bromo.
See, in my head it sounded right, but it just came out.
It's going R. Because the hydrogen is back.
So what is it, R or S?
It's R. It's R.
1,
2. Yeah. 3.
3. So this is rotating that way.
It's S.
The hydrogen, is it in the back?
Yeah.
Yes.
Okay, so this is
S. 1.
S.
Yeah.
So this is called S, 4 bromo, 2 methyl,
2 hexane.
2 hexene.
Okay.
That's cool.
And if we had more than one chiral center in that molecule, we would also put the parentheses even if it's in the middle of the name.
Professor, why is it 2 hexane again? I know hexane.
Hexane, no, hexene.
Yeah, why is it 2?
Why is there a 2?
Because it's on the second part.
Oh, there's a double bond.
Yeah, okay.
Oh, where
No,
did the double
that's a
bond
good
is?
question.
Oh,
Okay,
two?
that's a good question.
Oh,
I
yeah,
could say,
exactly.
why not 3 and 2? Well, it is 2 because you, so, because you start counting the chain here.
Right.
As you start putting the numbers, you are going to write the number where the carbon
Double bond
begins,
starts.
where the double bond begins.
Okay. Okay.
Now we get another one, yeah. Harder one.
5, 6.
So let's say,
If you have 2 double bonds, it counts in the name. Now you have to account for it, each one. So it's 2, 2 then, 2 comma 2. For the 1, 2, 3, 4, 5, 6, for the hexene. So 2 comma 2. And then start on the left. And 1, 2, 3, 1, 2. So it's what position? The BR is in the front. So 1, 2, 3, 4. 1, 2, 3, 4. Wait, 1, 1, BR is 1, 2,
Professor, what I
3.
call
So 1, 2, 3, 4. So it's supposed to be S, but it's really R.
No,
Or is it because of other committed
no, it's because where you start the chain,
On the left.
but bromo goes first because it's first in alphabetical order.
alphabetical? But you know we have two of them. If you start from the right, then you get one double bond a higher number than the other one. Because then, no, it's not wrong. So if you start from the left, that double bond will get a lower number than the other one. That's possible. Yeah. So let's start from the right.
It's really R.
No,
Okay. 1, 2.
bromo goes in the B.
Should be
I'm just being
2
oh.
bromo.
Okay, now we can modify.
2 bromo. R, 2 bromo. 1, 2, 3. 3.
I got R because I got S and you from it. Because H is
3. 1,
1.
2, 3, 4. 4 plural.
Yeah, triangle gets S. The triangle
Four
gets
plural. 1, 2, 3.
right, goes for the back.
Three, 5 hexene, maybe.
Yeah, you're sure.
3, 5
Because H
hexene.
is in front of making it R.
5. So 3 and a 5 hexene. I would start on this side, not that side. The double one is priority over the group? Priority over the groups? The double one has priority over the groups?
It's in one, so it's BR. So right now, it's on the right.
Okay, so it's backwards. So it's R,
You can count.
but it's really 1. Okay, so 1, it's 1, 2, 3. So it's 1 and 3. 1 and 3 hexene. And then it's 4, it's 1, 2, 3 plural.
B, our BR is 1.
And 1, 2, 3, 4, 5 bromo.
1, 2, 3. 1, 2, 3.
And it's R. 1, 2. Okay, I think I got it.
All right, let's do it, okay?
You don't have
So,
Start from the right.
we're gonna start from here, yes? Because this is the first attachment for the double bond. 1, 2, 3, 4, 5, and 6, yes? Now what I have is double bond, 1, comma,
3,
1,
2, 3.
1, comma,
3
3.
hexene. Hexene. Oh, oh yeah, dihexene because it's
Is
2.
if it has
Oh,
two double
yeah.
bonds, you are going to say diene.
Oh, diene, not hex. So
You
the
are
hex,
going-
drop the hex.
You are going to say hexa, diene.
Oh. Diene.
That's okay, the struggle will teach you.
Hexadiene.
Hexadiene.
I die. Hexadiene.
And what else do I have? I have a 3
You have a
chloro.
3 chloro.
Now you spell chloro?
CHLO.
Close enough, yes? And this is,
A 5 bromo.
and you gotta determine what this is.
And it's
Alright,
really a S, but it's
so
changed to a R.
1, 2, 3. From the looks of it,
It's really,
it's going S, yes?
yeah, so it's really a R because the hydrogen is in the front. So
It's
it's really a
R,
R.
5 bromo,
5 bromo. And so bromo is
Three.
first, chloro, and
Chloro.
1,3 hexadiene.
1,3
Hexadiene. Cool.
hexadiene.
Yeah, very nice.
Nice.
You like that, don't you?
I like that one, yeah.
Okay, do the other one, see if you learned anything.
Oh. Cyclo.
What's the name of this?
Cycloalkene. No, it's not an alkene. 1, 2, pentaene. Cyclo 1, 2, 3, 4, 5. Cyclopentaene.
Pentaene.
Sounds good.
Pentadiene.
Oh yeah, because of the 2. So pentadiene. Ah, okay.
So,
Cyclopenta.
what carbon is this, my friends?
Diene.
This is carbon 1, 2, 3, 4, and 5, yes? This is carbon 1 because there is a substitution is there.
Yeah.
Put it any other place will not give you the lowest number for that substitution. So this is 1 methyl, 1 comma 3
Pentadiene.
cyclo.
I mean, cyclopentadiene.
Penta,
C-Y-C.
Diene.
Professor, you started.
no, not cyclopentadiene.
No?
Cyclopentadiene.
What's the difference? Same thing.
We make that one the first carbon because it has a substitution.
Yeah, to count.
Well, I thought it depends on the double bond.
The lowest.
I mean, you are giving
No
them.
bond is there.
Double bond is perfect. But they're
If you start
together.
anywhere else, that will not get one.
So we want to try to get,
Matter which one.
Never get the lowest number possible.
but you
Ever.
prioritize double bond for which one?
No, yeah, you
can ask.
prioritize whatever comes first.
Are you sure about that?
You can
So if it was
Yeah,
having a
but
double
you
bond on
can
2
still
as
because
opposed
it's
to having
cyclo.
substitution on 1.
There's no
you would use
substitution, so it's generally doing the word cyclo.
What about on that
Diene. Pentadiene. That
Started
is.
off on the right side as opposed to the left.
Yeah, because double bond is on number 1.
Yeah, because it would be 1 or bromo would get 2. So 1 is, yeah. If you start on the right, double bond would get 1.
What if you
Start
had
on the left, bromo would get
cis
2.
with our what's your juices? How would you name it?
That is cis or trans.
It's either or.
That one is trans. I mean cis.
Well, no.
It's on opposites, right?
Oh, actually,
It's trans, no?
Professor? What if the bromo was on carbon 6?
Well, it's not really mirror image because that metal group
You still
is
be
not mirror image. But it's
Then you prioritize.
Okay, guys. Is that it?
yeah.
You guys want to call that a day?
You could add a cis or a trans and make it really
Stop that, please.
Oh, sorry. Yeah.
How much time is that?